Assalamu alaikum. Bismillahirrahmanirrahim. So today we will start our 7th week lecture, lecture number 13 and 14. Before starting of this lecture, I would like to address attendance issue which have created from the last 2 days. People, students especially, confused from the lecture view attendance by the actual attendance. So I rectify this problem even in the comment box, and when I'm uploading it I also mention it, but still lots of students have complained about the attendance, that they have taken the classes but the attendance is not right there. So by even explaining again and again in comments box that it is not a live session attendance, the first two tab is for lecture view attendance and the third one is the actual attendance. Still there's a misconfusion. I also rectify in the live session, but even in the this lecture I want to address this problem, so you might not misconfuse in future too. So this is the actual attendance, and don't view this attendance from directly from the classroom, because when you open that in the classroom tab, it will in the disorder form and you will get confused. Download it and open in the Excel software, Microsoft Excel. So you can see, like here you can see that it is the first two tab of the attendance is week 3 lecture view, lecture number 7, and lecture, that is a view attendance. When you open the classroom tab, the actual video of the lecture 7 and 8, when you open that video, your attendance will be automatically noted by the Google Logs, and we are getting this attendance directly from Google Logs. I didn't mark this attendance. So you have to watch this lecture on a specific week, like it uploaded on 22nd of June, July, sorry, 22nd of 22nd of June, and the time for this lecture is still and will be and in on 29th of June. So you have to watch between 22nd to 29. If you watch them in between this time period, your attendance will be marked automatically by the Google Cloud Logs. And if you don't watch them, if you watch them in later, the attendance will not mark. So in future, be careful for that. Till right now, these attendance is only for the record, for keeping the record, how the students are tracking with their lectures. The management didn't decide it yet that what they will do with that attendance, but in future it might be considered for a sessional marks or for actual attendance. So in future, be sure that you will watch that lectures on a specific dates. The reason for uploading this lecture, just to address you people, or just to aware that you should view lectures on the specific week. So when you come on the live session, you already watch that lecture video. So in the live session you get the questions, you have questions to ask, not just a revision of the lecture which we are doing right now. In future I will ask the question before starting of the, so I get response whether you people have watched my lectures videos or not. So let's move on. So be careful for the next time. Recently I uploaded a video on the Monday, so you have to watch till Saturday night. There's also time difference between in Google Cloud and our time. There's a GMT 7 and we have GMT 5. No, they are GMT 9, I think. So there's a time difference. When I just get the recording of the lectures, I also noted that there is a time difference of Google Logs and our Karachi time. So you be flexible on time too. Don't just watch them on the Sunday before 12 p.m. Watch it till Saturday night maximum. Okay, so let's move on towards our lecture. Yes. Now example 513, or no, it is not example, it is a question of Sanjil book, chapter number 5. In the lecture, it is the last numerical of the open system. After that we will shift towards Rankine cycle, Carnot cycle, and first we discuss terminologies, then we study the laws, second law of thermodynamics, then towards Carnot cycles and their numericals. Okay, so it is also very interesting numerical, and it is related to your infrastructure design. Uh, a smoking launch is accommodate 15 heavy smokers. The minimum fresh air required for the smoking launch is specified to be 30 liters per second as per ASHRAE standards. 62 1989. Determine the minimum area required flow rate for the fresh air that needs to be supplied to the launch, and the diameter of the duct if the air velocity is not exceed 8 meters per second. First of all, I would like to explain the terminology, that is ASHRAE. ASHRAE is basically Mechanical Engineering Society. As you also have societies in civil engineering. Similarly, in mechanical we also have these kind of society. The abbreviation of ASHRAE is American Society of Heat, Refrigeration, Air Conditioning. Okay, so this is the full format of ASHRAE, American Society of Heat, Refrigeration, Air Conditioning. And these are societies basically standardize the systems of HVAC, MEP, that we work, that we are giving consultancy to the clients and to the contractors. So these 30 liter per second is also defined by ASHRAE. Every human being is needed to have 30 liter per second fresh air. So you see that in normal rooms, split especially, we don't have a option of fresh air. It just recirculate the air in the room. So it gives very negative impact, which the rooms which are very heavily closed, or there will be no option of air coming or air out. So the air in that rooms becomes very oxygen deficient, and due to that low oxygen, people are in the low activity zone. People are trying to sleep, they are tending to sleep. So it is also not very good or healthy air, especially in the rooms, in the split ACs. In the central air conditioning, we have a fresh air duct. So part of the air is recirculated taken from the room, and part of the air also taken from a fresh air from outside of the room. So mixing those air and then send into the central air conditions rooms where it is implemented. So it is also bring new knowledge to you peoples for civil infrastructure. Even in the central air condition, we also have the duct of fresh air. That is a requirement of the human person. And in every big company, there are smoking zones. Like I've experienced in English Private Limited, so they also set up smoking lounges and smoking zones separately, so people will not smoke in the production facility, etc. Similarly, in this 15 heavy smoking zone, we have to induct fresh air. And how much fresh air? Per person, it is 30 liter per second as per ASHRAE standard. So for 15 people, we simply multiply by 30 liter into 15. Let's solve this numerical. It is very simple and easy numerical. Here it is, new document. Yes, first of all, find out the amount of air, that is volume flow rate, V dot, is basically uh, 30 liter per second per person, multiply by there are 15 heavy smokers, so we just multiply by V dot, that is 15 liter per second. Okay, after that we have to convert into the meter cube per second. So can close this now. Yes. 1000 liter is 1 meter cube. So by converting this 15 liter into the meter cube, we have to divide with this with 1000. Then we will get the volume flow rate. Okay. Now 30 divided by 15. Sorry. Is 15 divided by 1000, we'll get volume flow rate. It is 0.45 meter cube per second. Okay, it is 40.45 meter cube per second. So we get this volume flow rate for the whole room. Now to calculate the area, simply we will calculate the area, and then from the formula of circular duct we can calculate the diameter. So now we have a V dot, that is 0.45, and V dot basically what is the formula for volume flow rate is V dot is equal to area into velocity. The formula of volume flow rate is simply area into velocity. This is new formula. You can note this formula too. This is velocity. We can write this like this to differentiate. This is velocity, not volume. V dot volume flow rate is equal to area into velocity, and the unit will be the same. The unit of area is meter square, and the unit of velocity is meter per second. So multiply by meter square into meter will be meter cube per second. So it is the same for the volume flow rate. Yes, we have unit here, meter cube per second. So now we can open this area. We have to find out area. We know the velocity from the numerical. Yes, you can see this even in the, why it is not getting zoom, I don't know. Anyway, I don't know why it is not getting zoom. Yes, you can see that the outlet duct is round, so we have to apply the formula for even for the area is for the circular duct, and the velocity 8 meter per second. So we just apply the velocity over here. Velocity is 8. Velocity is multiplying here by going on the right side, it will be divided by 0.45 divided by 8. So area is 0.45 divided by 8 will be 0.056 meter square. Okay, to find out we get the area, and the formula for the area will be pi d square upon 4, and if we apply root on both sides, the d will be 4a divided by pi. So we apply the value of area 4a multiplied 0.056 meter square divided by pi value 3.14, and we get the answer 0.26 meter. And if we write it on centimeter, it will be the dia will be 26, simply multiply by with 100, 26.7 centimeter. So this will be the answer. This will be our answer, 26.7 centimeter. Thank you. We will start next lecture, inshallah.